Okay, for this review, we're going to work on Algebra 2 Review 2. This is the second review for the IA. So let's look at a couple of problems that we had. This one is actually fairly straightforward. We just have to put it in the right form. So the first thing we want to do is, when we start with that, we want to get it in the right form. So get h by itself. So I'm going to get rid of this, add h to both sides, and I have this right here. Subtract 40, square root of 45, and so I have basically this right here. Square root of 80 minus the square root of 45, which of course you can't do anything yet, but because these numbers are different, we can't combine them yet. So we have to simplify each one. So the square root of 80 is 2 times 2 times 2 times 2 times 5 is 80, so the square root of that, and then 45 is 3 times 3 times 5. So now that looks like when I do that, I'm going to have let's get a different color. I have these 2's come out and these 2's come out, so one of them cancels out and the other one comes out in front. So one in front, I'm going to have 2 times 2, that's 4 square root of 5. And here the 3 comes out, so 3 square root of 5. So now the simplification of that is quite simple. 4 minus 3 is 1, so h is the square root of 5. All right, next problem, number 2, looks like this. In solving problems with a square root in it, we have to get the square root by itself. That's always the first step. So for this one, the first thing we're going to do is subtract, this is what we start with, we're going to subtract 10 from both sides. And when we do that, we end up with this situation right here. Now, if I square both sides, I'm going to get this right here, 6x, the square root of a square cancels itself out. So 6x, negative 6 times negative 6 is 36. Now when I divide both by 6, I get x equals 6. Now, but always with the square roots, we want to check our work. Did it work out correctly? So now, why is this not in here? How do I get this over there? Let's see what we got here. So 6, square root of 6 times 6, I'm just replacing the x here with the 6. So that's 36. The square root of 36 is 6. 6 plus 10 is 4. Actually, it's not 4. So there's no solution to this one. This 6 does not work. So the answer to this one here is no solution. We probably could have looked at this right here and realized that already right away we can see there's no solution, because the square root can never be a negative number. The square root of something can never be a negative number unless you're looking at imaginary numbers, which, unless they say imaginary numbers, we don't use imaginary numbers. Okay, next problem here was the same type of problem. So first I'm going to subtract 7 from both sides, and I end up with square root of 2x equals 4. Now I square both sides. So square root of 2, the square root squared just gets rid of that until I have 2x. 4 squared is 16. I divide by 2, I get x equals 8. And then the check for that, the square root of 2 times, I replace the x here with an 8. So that's square root of 16 plus 7 is 8. 11. 4 plus 7 is 11. That checks, so that is the answer. 8 is the correct answer. So that's what we put right here. Again, if it's a multiple choice test and you don't know how to do this, you forgot how to do this or whatever, you just check each of the answers. 2 didn't work, neither did 4. None of these work except for 8. Okay, this problem has a little bit more of a trick to it because we have this x over here. The procedure is still the same. Isolate the absolute value. So that's the first thing we're going to do, is isolate that absolute value. So we subtract 3, and I get the square root of x plus 3 equals x minus 3. Now when I square both sides, I have to remember I'm squaring the right side. It's not x squared minus 9. It's x minus 3 times x minus 3. If I did the FOIL for that, I'm going to end up with this right here. I'll leave that to you. Did I do that over here? No. So now what's going to happen is that's going to be a quadratic equation. Now, there's a couple of ways we've learned to do this. One is completing the square. Easier if we can just factor, though. We want to set one side equal to 0. So I'm going to subtract x from both sides, and I end up with 3 equals x squared minus 7x plus 1, because negative 6x minus 1x is negative 7x. And then the next step is to subtract 3 from both sides, and I have this right here. So now I have something equal to 0, which is what I'm looking for. Oh, where's the rest of the problem? Let me see if I can do this. Okay, hold on a second. Well, let's just do this right now. So now I'm going to factor this. I'm going to say 0 equals, and I'm going to factor this, x and x. That gives me x squared. Two numbers that multiply to 6 and add to 7. That's 6 and 1. They both have the same sign, both minuses. Here, that doesn't mean we've solved it. Now I have two things multiplied to equal 0. So one of them has to equal 0. It doesn't matter which one. I think I did this right here. Let me just check this. Yeah. So that's what it factors to right here. 0 equals x minus 6 times x minus 1. So now that means either x minus 6 equals 0, in which case x is 6, or x minus 1 is equals 0, in which case x is 1. So there's two solutions, 6 and 1. So first we're going to check 6. I put in 6, 6 plus 3, square root of that equals 6. Notice in the red is where the x's were. I changed them to 3's. And that gives me square root of 9 plus 3 equals 6. 3 plus 3 is 6. That works. 6 is a solution. When I check 1, 1 plus 3, square root of 1 plus 3, notice the two red ones. That's where the x's were, over here and here. And so that leaves me with square root of 4 plus 3 equals 1. 2 plus 3 equals 1. No, it does not. So 1 is not a solution. We call that an extraneous solution. But 6 is the only true solution to this, so D would be the correct answer. All right, we're moving through. Now this one here, we got to remember our rule that we did before, exponent rule. Here, this is the rule we have, a to the m over n. Notice the denominator goes in this little spot here, and the numerator goes out here. Sometimes they'll put it right inside here, but either way, it's an exponent, the top number. If this is a 2, like if you had 1/2 or 3/2 or something like that, this can be left blank because when there's nothing here, it's an imaginary 2 or a visible 2. So basically what we're doing is this number here is going to be the denominator of my fraction, and this is going to be the numerator. So 2 over 5, 7 to the 2 over 5 power would be this one right here. This would be my solution to that problem. Because 7 is the base. 2 is the top of the exponent, would be the numerator, and 5 is the denominator. Okay, same problem with this one. When we use the exponent rule again, as I said before, sometimes the exponent here can be put outside, sometimes inside. In this case, they put it inside, so that's just going to be the base is 6. The bottom number goes here, and the top number either can go here or sometimes up here, but they left it here for this one, so we're looking at this answer right here. Okay, let's look at the next one. This one actually wasn't one of our problems. It's in the future. I'm not sure how I got it in there. That was a mistake that I put it in there, but let's see if we can do it anyway, see if we can remember how to do this. Basically, it kind of tests our ability to look at something that we've had a long time ago and combine it with something that we sort of just did. Let's work on factoring. Can we factoring this? First thing we always look for is common factors. So common factors would be x parentheses x minus 3 right here. And this one factors to be x minus 3, x plus 2. Two numbers that multiply to 6 and subtract to 1. That's 3 and 2. Bigger number gets the minus, and that's what we get. In the bottom, when we factor this, we're going to have x and x to multiply to 10 and subtract to 3. That'll be 5 and 2. Bigger number gets the 5, and then that's it. And this is a difference of squares, x plus 2, x minus 2. So that's good. And now we say, wait a minute, I remember something a long time ago about dividing fractions. When we divide fractions, we have to flip the second fraction upside down. So actually what we have is this. And now in fractions, when everything is multiplied together and everything is factored, which we have here, we're just going to cancel off things that are on top and bottom, because technically that's just 1. X plus 2 over x plus 2 is 1. We're going to cancel that. Let's get a different color in this. We'll cancel the x plus 2's and the x plus 2's. We'll cancel x minus 3 and x minus 3, because remember when we multiply fractions, you just multiply the whole top and the whole bottom. And then x minus 2 cancels with x minus 2, and what we're left with is x over x plus 5. So there's our answer there. That's not going to be on our interim assessment, but it doesn't hurt to remember how to do things like that. Okay, in terms of I here, that just means we're going to have this negative comes out of the square root. So that becomes 7i times the square root of 8, because the negative inside becomes an I outside, not a negative I, just a positive I. And now the square root of 8, 8 is 2 times 2 times 2. So now what I would do with this one is I'm going to circle these two. One crosses off, one comes out front. And now I have 7 times 2 is 14. So 14i squared of 2. There we go right here. Okay, next problem. Okay, this one here, find the roots means solve. That's all it really means. So we're going to have to go through the steps of completing the square. Our first step is going to be to, since 6 doesn't work, it's not half of this squared, so that's not going to factor. We have to move the 6 to the other side, so we end up with this. And notice how I left a space here, because we're going to put a new number here that would make this whole left side a perfect square. And to do that, we take half of 4, which is 2, and square it. So 2 squared is 4, so I'm going to put plus 4 and plus 4. If I put plus 4 on this side, to keep it equal and balanced, I have to put plus 4 over here. So now my equation looks like this. The left side can be factored to be x plus 2 squared, x plus 2 times x plus 2. That's going to happen, half of this number goes right here. And we picked it, we put this number so that this would happen. And then the right side is negative 6 plus 4, which is negative 2. Now I can take the square root of both sides. And when I take the square root, I want the plus or minus square root over here. So I have this, and now what I'm going to do is the square root of a square cancels, and I just have this right here. The I comes out as an I. So now I'm just going to subtract 2 from both sides, and I'm left with this as my answer. So negative 2 plus or minus I right root 2. That's C. All right, the next problem, number 10. We have to go back and remember these rules over here. You're going to have to memorize these. That's just something we'll have to do. So I to the 88, since 88 is a multiple of 4, that's just going to be I to the 88th is just 1. It's the same as I to the 4th or whatever, that's 1. I to the 22nd is the same as I to the 20th times I to the 2nd. Basically what I do is multiple of 4. I found the closest multiple of 4 less than 22, and that's 20, which this whole thing right here is the same as 1. And I to the 2nd is negative. 1 times negative 1 is negative 1. So this equation up here then becomes 1 plus negative 1, which is 0. So that's the answer here, 0. All right, let's move on. A couple of more. We've done this a couple of times. We have a denominator with an I in it. We can't have that, so we have to eliminate that I. To do that, we're going to multiply by the conjugate, the top and bottom. The conjugate of 1 minus I is 1 plus I. Okay, so the top of the fraction I just distribute. 2 times 1 is 2. 2 times I is 2i. The bottom we have to do a little bit of FOIL. 1 times 1 is 1. 1 times I is I. Negative I times 1 is negative I. Negative I times I is negative I squared, which works out the top then is going to be 2 plus 2i. And the bottom is going to be 1. These guys here will cancel. Plus I minus I cancel. So 1 minus I squared. Minus I squared is minus negative 1, which is plus 1. So then we end up with something that looks like this. 2 plus 2 over 2 plus 2i over 2. Divide everything by 2. 1 plus I over 1, or just 1 plus I. So that's the answer there. All right. The conjugate of a complex number. This is a complex number which has a real part and an imaginary part. The conjugate will be the same first number, negative 3, and the second part, they change the sign of this. So this is the answer A right there. All right, let's do a couple more. Okay, in the process of completing the square, we have to figure out what number is supposed to go here. Now, a lot of times, it's basically going to be half of this squared. The problem with half of this is it's going to be a fraction or a decimal. A lot of us would write this as half of that is 2.5. 2.5 squared is 6.25. Now 6.25 isn't the answer written here, so let's use fractions to do that. So half of negative 5 is negative 5 over 2. And when I square that, I'm squaring that. So I square the top and I square the bottom. So negative 5 times negative 5 is positive 25. 2 times 2 is 4. 25 over 4 is the answer. If you use your calculator, that's fine. You get 6.25, and then you change that into a fraction. With the TI-83, it's math, enter, enter, and it gives you that fraction. Either way works. Okay, this problem, we just got to follow the steps of this. Which one of the following expressions is a step in solving? They're not asking you to do the complete solving. There's only one more step to do, but which would be a step? So you have to know all the steps of completing the square, because there's a couple of problems on the IA where they ask you to find out one of the steps. So you have to kind of know all of them. So the first thing we're going to do is get rid of this 4. Because this isn't the right number to complete the square. So I add 4 to both sides, move it to the other side, and I end up with this, which is fine. Notice I left a space because I'm going to put a number there. The number I'm going to put here is half of negative 10, that's negative 5, squared. Negative 5 times negative 5 is positive 25. So I'm adding 25 to both sides of the equation. At that point, we have the left side is going to be parentheses x minus 5 squared. Notice half of negative 10 is negative 5. And the right side is 4 plus 25, which is 29. And the next step would be to take the square root of both sides. If I take the square root, I can write this out. So if I took the square root of this side, and when I take the square root, I need plus or minus. So that's it. The final step for the thing would be, if we were going to do the final step, would be to add 5 to both sides. And I get this right here. They're asking for which one is the step. This is the step they're talking about. So this is the answer right here. That's the one they're looking for. They're not asking for the final. This would be the final answer. This is the step they're looking for. Okay. Next problem. I skipped one. Sorry about that. Okay. Again, it's the same principle as last problem. We're going to first, the 12 is not the right number, so we got to get rid of this 12. So we add 12 to both sides, and we end up with this right here. Notice I left a space. Half of 14 is 7. So 7 squared is 49. So I put 49 there, and of course, I didn't write plus 49 over here, but 12 plus 49 is 61. I guess I'll write that. It probably would look better. Let's go back to this one and fix this the way it's supposed to be written. 12 plus 49. Okay, so that equals 61. So this is what I have. X minus 7 squared equals 61. I take the square root of both sides, and I'm left with x plus minus 7 equals plus or minus the square root of 61. Again, we just take the square root and the square root plus or minus. And this is what I get right here. So that's the step they're looking for. If they did ask you to go to finish the problem, then we would just add 7 to both sides. And there's our answer right there. But they ask us for this step right here. So there's the answer right here. And the last problem on the work, it just involves simplifying. Now, what I would suggest, anytime you have parentheses added or subtracted or whatever, I would suggest we write the whole thing without parentheses. What am I doing here? So to do that, there's nothing in front of this parentheses, so basically it's like they don't really mean anything. So I just write this first set of parentheses as it is. But this minus distributes to each thing in here. So basically I can go negative times 7 is negative 7. Negative times negative 8 times positive 8 is negative 8y. Negative times a negative is positive 4y. Negative times a negative minus 6y cubed. And now we got a couple of things we can do. We have to basically combine like terms. My method, I did this in, let me get rid of this thing. I use different colors. Now, of course, we don't have colors when we're dealing with pencils, so maybe a better way to do this would be to, let's just start with the highest power is y to the third. I'm going to circle those right now. These are y to the third, and these are y to the third. So I have negative 3 minus 6 That's going to be, oh, I erased it here, negative 9. Sorry about that one. I erased this 9. So negative 9 y to the third. Y to the thirds are done. Let's get a better color. Next thing I'm going to do a look at is y to the seconds. I have y to the second there and negative 8 y to the second. So 1 minus 8 is negative 7 y to the second. I'm done with those guys. Now I'm going to go to the y's. I have 5y plus 4y. That's 9y. And I'm done with those. And here I have negative 2 minus 7, negative 2 minus 7, negative 9. So that would be your solution. A. Okay, I think that's it. There's no more problems on that worksheet. So hopefully that helped a little bit. Just make sure you go through and know how to do all those. And you'll be fine on the IA if you can do that. Okay, thank you.